All right, this video is going to review the Pythagorean theorem. So we're going to just jump on in. So first of all, Pythagorean theorem applies to right triangles. Now we are going to use it later on in geometry to determine if a triangle is obtuse or acute. But for this purpose, the purpose of this video and this exercise is just to check and see if a figure, or we're going to have figures that are right triangles. Sorry, I'm trying to move stuff and talk at the same time. All right, so first of all, here's our right triangle. A couple of things that we need to be aware of is that in this right triangle right here, this is our hypotenuse, okay? I'm just going to abbreviate it. A hypotenuse is always the longest side, so it's always the biggest side of the right triangle, and it's always across from the right angle. So here's the right angle right here. So that's where the C in our formula comes from. A and B are interchangeable, so it doesn't really matter which one you call A and which one you call B. Most people call B the bottom, the base one, and A like an altitude, but it doesn't really matter. It's not going to affect the problem at all because we're doing addition, and remember addition is commutative, means I can change it in different orders. All right, so then the formula is a squared plus b squared equals c squared. Remember we watched the video of how Pythagoras came up with this, and we had a visual to look at. So we're going to actually do this on the back. So before we go any further, I want to list the Pythagorean triples, or some common Pythagorean triples. So there's just some common triples that I had to memorize when I was in school. Most kids do, but they're ones that you're going to see a lot throughout the book. You'll see them on the ACT. So 3, 4, 5 is a triple, 5 being the hypotenuse because that's the biggest number, 3 and 4. 6, 8, 10. Sorry, I said 8 and wrote 10. Let me see, find an eraser here. Okay, 6, 8, 10 is a triple. 5, 12, 13 is a triple. Let's see, there's several of them, but these are common triples, and so you can Google Pythagorean triples, and if you'll memorize them, it'll make things a lot easier. All right, so I'm going to clear this, and let's go to, the next slide. So let's look at this together. So I'm going to mark this as a right angle. Make this 4 and this 5 and this x. We're going to find x in this one. So looking at this problem right here, the first thing I need to do is always identify the hypotenuse. So I see right here is the hypotenuse. It is across from the right angle. It's the longest side. It's visually the longest side. So I'm going to come out here to the side. I have a squared plus b squared equals c squared is the Pythagorean theorem. And so I'm going to plug these numbers in. 4 squared plus 5 squared equals x squared. Okay, so I've got 16 plus 25 equals x squared. And then I'll add 16 and 25 together. So I get 41 equals x squared. And then to get rid of this square, I have to square root. I'm going to change colors here so you can see what I'm doing. Square root both sides. And what that does is that cancels out their inverse operation. So it cancels out the x squared. So my answer is either root 41, depending on what your teacher's going to want you to put. So if it was a ACT question, it's probably going to be a radical form. And then you could simplify if this one will simplify, this one won't simplify. Or you could type in square root 41 in your calculator. And when you do that, most answers, you'll need to go to 2 decimal places. So this one is 6.403. And so remember, this 3 tells us that that 0 is going to stay the same. So my answer is just 6.40 would be my value for my hypotenuse. Always verify your answer. So when you get your answer, remember this is the longest side. So this number right here needs to be bigger than the 4 and 5. If I get an answer and it's smaller than 4 and 5, I did something wrong, and that's the way I need to go back and check myself. All right, let's go over here and do a second one. So I'll move that out of the way. So let's come over here. Here's my right angle. Let's call this X, this 6, and this 12. Okay, so when I look at this, the very first thing I always do is identify my hypotenuse. So this is my hypotenuse. And it's, see how it is across from the right angle. So that's how I know it's the hypotenuse. So now I've got my formula, a squared plus b squared equals c squared. So I'm going to plug in my numbers. It doesn't matter which one I make a, which one I make b. So I've got x squared, because I don't know what this value is right here, plus 6 squared equals 12 squared. So x squared plus 36 equals 144. And then this looks like an equation that I would solve. I would need to get rid of 36 on both sides. So x squared is equal to 144 minus 36, which is 100. Oops. And then to find out what this is, remember I have to do the inverse of squared. I'm sorry, it's 108. I thought that sounded, I was like, that's not a triple. All right, so I want to get rid of this square, so I'm going to square root both sides. So that causes that to cancel out. And then x is equal to the square root of 108 is 10.39. So either 10.39, 4, again, depending on what your teacher wants. You could say root 108, but this is probably going to simplify. There's probably some perfect squares in there that I could pull out. However, we haven't done simplifying radicals in this year, so I'm going to go with this answer right here. Khan Academy usually takes this. It doesn't even make you simplify it. We will eventually simplify it because the ACT will want us to. All right, let's move down here to number 3. The other thing you're going to be asked to do is they're going to give you 3 sets of numbers. So 23, 18, 14. And what they're basically saying is, do these 3 numbers, do they form a right triangle? So like say this is 14 and 18, and then this is 23. Doesn't matter where you put the 14 and 18, but the 23, seeing as it's the biggest number when I look at it, it has to be over here at the hypotenuse. So if I use the Pythagorean theorem, a squared plus b squared equals c squared, and I plug these numbers in, 14 squared plus 18 squared equals 23 squared. Does this equation balance is basically what it's saying. Does it work out? So I'm going to type all of this in my calculator at one time. So I'm just going to type in 14 squared plus 18 squared and let my calculator do all of it for me. So this right here is 520. Sorry, that's a terrible 520. And then I'm going to come over to the other side. I'm going to type in 23 squared in my calculator. Really, I should put my glasses on. Sorry. 529. And so we can see that these are not equal. The symbol that we use in all math, but particularly we're going to use this a lot in geometry. When something's not equal, we draw this line right here. And so if I asked you, do these three form a right triangle? You would say no. And the reason, explanation is right here, because they do not equal. Okay. So when I use the Pythagorean theorem to test for something is with that, a right triangle. All right, let's do one more. Sorry, I was trying to change colors. So looking at these numbers, see how this is the biggest number. That means that's the C. So these are the A and the B. I'm not going to draw a figure this time. We'll just go straight to the formula. A squared plus B squared equals C squared and plug these numbers in. So 45 squared plus 28 squared equals 53 squared. And so now I'm going to type this in my calculator. So 45 squared plus 28 squared is 2,809. So 2,809. And then I'm going to type in 43 squared, and I find out that that is also 2,809. When these equal, so notice these two, this is a balanced equation, these are equal to each other, then my answer is yes. This is a right triangle. So this is my explanation right here, is that those are equal. All right, that is the Pythagorean theorem.